Hi everyone. So given our exciting discussion last week about measures of central tendency and spread in data sets, I'm sure you all are very keen to see how we take the measures of central tendency that we identified, which is our mean and our median, and we use them to calculate these measures of spread. And again, the point of the measures of spread and central tendency taken together is that they help us characterize data. It lets us characterize individual data points and understand if they are typical or atypical. And it also helps us understand just sort of how the data is organized, right? It lets us observe trends and anomalies, basically, or outliers. For this part of the exercise, I'm going to quickly redo our measures of central tendency and spread. I'm going to work with just the July 1st data from our Jersey City data set, so it's not quite so large as it was. And I'm just going to repeat very quickly here for review the steps that we did last week. So for starters, I'm going to go ahead and sort my data. I know my interface is a little bit different from yours, but I'm going to start by sorting on trip duration. And that is going to mean that I can do a couple of things quite quickly. Of course, I'm going to label my mean. I'm going to say equals sum. Right, I open my round parentheses, I'm going to select all of my rows. Okay, and then of course I need to know how many rows I have. I'm guessing I have 32. Yep, 32. And I'm going to divide that by 32. And I'm going to get 709.5. So that is my mean, or average as we might call it. Now the median, of course, I need to find the middle row. So here we go. This was a lot of fun last time. So if I have 32 rows, right, 32 rows of data, I'm going to do 32 divided by 2 is 16. I'm going to add 1, of course, because I have one header row here. So I'm going to go to row 17. But it's not going to be just row 17 because this is an even number of rows. It's actually going to be 2 rows. Right, because the middle would be between 17 and 18, right? But there's no data point there. So for our method, what I like to do is take the two and average them. There are a few different methods of calculating when you have an even number of rows. The most important thing is that you remain consistent. So for our purposes, we're going to do this, and of course that means that our median is the sum of these two numbers divided by 2, right? So 440.5. So I'm just going to double check because I like to be careful, right? So I have 15 rows on one side, and I have 15 rows on the other side. Just what I was hoping for. Now, in this case, I want to also find. Now, I also need to find Q1 and Q3. Okay, so Q1 again is taking the middle. It's like the median of the smaller half. Right? I'm just dividing that smaller half in two. I prefer to do this excluding the median. So I'm going to take this as 15 rows of data. So I'm going to take 15 divided by 2 is 7.5. I round up to 8. And then, right, 15, yeah, okay. I round up to 8. And then I'm going to add 1 because I'm discounting one row, which is my header row. And let's see if I got this right. And it looks like I have 7 on one side and 7 on another. So my Q1 value, again, Q1 is not 9. It's not the row number. It's the value that appears in that row number. It's going to be, looks like it's 360. Okay. And Q3, I'm going to do the same thing, but I'm going to do it for the upper half data, right? So in a small data set, I could just maybe count down by 7, right? And say it's this one. Or I could say, again, 15 divided by 2 is 7.5. I round up to 8, right? So I'm looking for the 8th row, but I am excluding 18 rows of data, right? So if it's 18 plus 8, right, that's going to be 26, right? And I think that's the same result that I was expecting, and indeed I have 7 rows on one side and 7 rows on the other. So I realized this was very confusing when we discussed it in class last week. It inspired me to sit down and actually think it through. So I appreciate your patience with me, but hopefully it's pretty straightforward now how to calculate this. Okay, so those are our measures of central tendency. Now we want to get to spread. So the first thing that we're going to do for spread is we are going to calculate something called, we're going to calculate the standard deviation. Now, having just done all this, I am actually now going to move it, and I'm going to move it over here, and the reason why is that I'm going to start to have to add columns of data. This doesn't seem to like this. I don't know. Okay, I'm not going to do these whole rows. Sorry. I'm just going to do these cells. Okay, and I'm going to get rid of them, and I'm going to move them over here. And the reason why I'm doing this is because I'm about to add some columns, okay? So first question, how do we calculate standard deviation? It's a pretty powerful metric, but what is it actually composed of? So here we are. Okay, so Wikipedia, often our friend. Oh, sorry, this is not fully on screen. Okay. So this is one of the quote-unquote basic examples, and I think this is a really handy one to see worked out. I think it's helpful to see these things worked out with smaller data sets. Now, the key thing is this sentence here, okay? For a finite set of numbers, the population standard deviation is found by taking the square root of the average of the squared deviations of the values from their average value. That is a mouthful, okay? So what we're going to do is we're going to actually break this down into component steps so you can see how it's done. And really this is just converting language into, converting written language into individual steps. So the first step is we're actually going to work backwards through the sentence, right? So we're going to start with deviation or difference, right, of the values from their average value, okay? So what does that mean? That means that I need to take every value in my data set, okay? So I'm using trip duration here. So I'm going to say difference from, and what is it asking me for? It's saying the deviations or the difference of the values from their average value. Well, what's the average value? It's the mean, right? It's the arithmetic mean. So I'm going to say difference from mean, and I'm going to create a formula that says, look, start with this number and subtract the mean. Right? Simple as that. Now, for those of you not familiar with Excel, here is a handy trick. If I have created a formula in a given row and column, if I copy that formula, it will sort of sensibly move it down for me. What do I mean by that? Well, right, this one is referring to A2 and S2. If I copy this down, it's going to move it down for me as well. However, seems promising, except that I like the fact that the row number for the A part, right? I want it to look at this value. That's correct, right? But I don't actually want it to move down to S3, right? So S2 is my mean, right? S3 is my median. That's not what I want to be working with here. So here's a trick. I can tell Excel, okay, when I copy this formula, you are going to shift, if I copy it down a row, you're going to shift the reference down a row, right? If I'm in row 2, you're going to say row 2. If I'm in row 3, you're going to say row 3. However, I can stop that for parts of a formula by putting a $sign in front of it. And what this does is it means that although the first part, the A2 part, will change and move down each row, so A2, A3, A4, A5, the S part will not. That $sign freezes it, fixes it to just be that too. So let's take a look. No. Okay. See how it's staying the same? So that's important, of course, because if I didn't do that, then I wouldn't be subtracting from my mean anymore. Now, of course, you could say, well, I could just take this, I could just type in the number every time, right? We never want to do that because one of the great values of working with formulas is that if we did something by accident, let's say we went back to our data set after we did everything, right? And we realized, oh my gosh, we left out a row. Well, that would cause a lot of problems if we had entered our numbers manually. Sometimes those manually entered numbers in programming are referred to as quote unquote magic numbers, right? Or hard coded, right? It's something that you have written in to this specific value. And you always want to avoid that because we never know when things might change, either because we get new data or again, we discover an oversight or an error. So we always want to be using formulas wherever we can in order to keep our work dynamic and resilient against, again, errors or oversights. So there we go. We've got the difference from the mean. Okay, so that's the first step. The second step is we need to square it, okay? It's saying take the square of those differences. So pretty simple. I'm just going to insert another row here, and I'm going to say square of difference. Okay, and I'm just going to do this individually for each one. So what is this? This is this times itself. Simple enough, right? And I can just move this one down as it is because, of course, I'm not trying to reference anything that stays the same. I'm just using that individual cell. Okay, so making good progress here. So squared deviations of the value. Okay, take the average of the squared deviations of the values from their average value. So again, I'm just working backwards here. I'm not worrying, I'm just taking this one step at a time. So I say the average of the squared deviations. Okay, well, I know how to do the average, right? I can just say, I'll do one over here that's square of average. Okay. So wait, no, it's not the square of averages. It's the average of the squares. Gotta be careful there. Average of squares. Okay. So now I have the average of the squares. And what is that, of course? But it is, we're going to do the same way that we did our mean, right? We're just taking the mean of this thing. So I'm going to say, okay, give me all of these things. I'm going to divide by, oops, close my parentheses, important, divide by 32. Okay, so there is the average of the squares. Final step here, square root. So I'm going to come back here and I'm going to say square root. And that's just going to be another formula. And I think it's something like square root, yep, SQRT, right, of that number. Okay, so here we have, this is actually standard deviation. Okay, see, it wasn't so bad. Again, when it's written out, it sounds really complicated. When you break it down into steps, it actually comes out pretty straightforward, right? So what do we think of this? Well, we know that our mean is 709.5 and our standard deviation is a little over 600. So just eyeballing this, right? What I would want to know is, does it seem like the majority, at least the majority of my data values fall in that range? Well, we know that this would be at the bottom end. So again, going back to why does this matter, right? If we go back to our reference for standard deviation, what we see is that, remember, 70% of our values should fall within one standard deviation of the mean. Okay, so that means in our particular data set where we have a mean of about 700 and we have a standard deviation of about 600, we would expect to see most of our data points fall between values of 100 and 1300. Right? So obviously I'm not being precise right now. This is just, again, for eyeballing. So the question is, if I were to say 100, if I start everything that's above 100 and go up to 1300, I've got 26 rows, okay, out of a total of 32. Let's just do a little quick math. 26 divided by 32 is what? 81.25. Well, that's, yeah, that's kind of close to 70%, right? Now, it isn't perfect, and probably part of the reason is that this is almost certainly not a perfectly normally distributed data set, right? That is to be expected, right? We don't often run into actually perfectly normally distributed data, but it lets us know that, we're in the right ballpark. If we got some crazy, if we got a really huge value or a really tiny value, we would just want to double check our math. Okay, so ta-da, we have gotten to standard deviation. Fantastic. That's one measure of spread. Now we need to look at the measures of spread that go with our median value. So we'll come back in a couple minutes and take a look at that.